All right, YouTube says we're live, so we're live. Thank you for joining us this morning at a slightly different time than we've been doing, just because we're now observing daylight savings here in the U.S. And I think did I say celebrate or observing? That's what I said earlier. Yeah, no, this one I'm not celebrating. The next one I'm going to celebrate because I'll get an hour of sleep. But on this one, I had to wake up an hour early, so my body thinks it's 5 a.m. now, Eastern Standard Time. So, nonetheless, thank you all for joining. Looks like we got 29. Oh, never mind. I just jumped down to 12 concurrent viewers. So, welcome to all 12 of you. It's going down. What is my voice that bad? Hey guys. Cool. We're getting some people in the chat. What's up? I see some names I recognize. So yeah, today's stream, we're going to do the normal format that we've been doing, which is just do a little bit of a game development discussion the first, 30 minutes or so. And then towards the end, we'll try to take a look at the code that was presented in Sunday's video, which if anyone hasn't caught it, it's a video on the job system. I should say right now, I'm no expert. Jason would probably say he's definitely not only not an expert on the job system, but is completely uninterested in the topic. But yeah, I had to curb his description. But Jason's slightly uninterested in the job system and ECS, but hopefully that'll, breed some interesting conversations as we look at the code and talk about the many approaches. But other than that, yeah, if you have any questions in the chat, be sure to drop those in. And we'll get to it. I'm trying to think of, I remember we talked about something last time. We talked about the code. We refactored a little bit of code. Here's the real question. Does Jason's voice work? Yeah, I don't know, Jason. Does your voice work? I've been talking too much. Oh, you know what? He actually might be muted. Let's see. I like to mess with him and mute him. Here, speak real quick. You're definitely muted. Yeah, I know. This is what is first day. What's interesting is I don't even see my desktop in the mixer. So let me see if I can pull that up. Yeah, that's so weird. My desktop isn't even appearing in the mixer here. So, well, Jason, you didn't even want to be in the stream because it was about the job system, and now you might get your wish. Here, let me. But if there's any questions in the chat, feel free to drop those in there. While I try to figure out why the heck Jason is not coming through. Interesting. Let me pull up my chat real quick so I have that going. Free my man Jason, someone says. I'm sorry, man. That's so weird. I would say I have to restart, what do you call this thing? Streamlabs, but that would end the entire stream. It's probably coming through. Yeah, I'm gonna hold my face to the microphone so they can hear you. So, all right. I saw desktop audio has shown up. Now I just need to make sure I can point it to you. The other thing I could do is I wonder if I can pass in Zoom's audio. This is weird, man. I hate technology sometimes. As a programmer, anyone ever feel that? And someone says. Yeah. Oh, I'm reading your chat there. Good stuff. All right. So I see desktop audio device 1. I'm going to disable it and then I'm going to re-enable it. See if that works. Default. Yeah. Okay. All right. Say something. Yeah, this will be like the sound check clip. I think every stream's going to have a sound check clip. Well, this really sucks. I wish. Was that actually a question that came through? Oh, wow. Interesting. So the question that Jason, so I'm just going to be Jason's proxy for the time being. Yeah, he doesn't probably want to answer this question anyway because it has to do with dots. Have you yet figured out a way to properly architect your project using dots? I mean, again, I'll probably have to talk for Jason here on this one, but I don't think there is a way to architect. I think it's already decided for you. If you use Unity dots, the assumption is you're using Unity ECS, which leverages both the job system and the burst compiler. And Unity ECS itself is an architectural pattern, which I think is something that gets lost in the way it gets spoken about. Yeah. Jason's talking to me, by the way, guys. That's why I've stopped. But I'm going to repeat what he just said. That Unity, this is an interesting dynamic we have here. Unity itself is an architecture. The fact that you use mono behaviors and components, you are locked into some sort of architecture when you're using Unity. You have to drag components onto, at the very least, even if you wanted to bypass the whole thing, you'd at least need one. That's actually not true, because there is a way to override all that. There's some attribute, I forget what it's called, but it's like run static or something. So there's a way to run like some static code outside of mono behaviors. But I think you probably do need to implement a mono behavior even to take advantage of that. But yeah, so Unity is an architecture in itself. Unity dots ECS, that itself has a built-in architecture. You have to, your whole game is made up of systems that operate on components, and those components live on entities. So when you actually set your project up for Unity dots, ECS and all that, you're pretty much locked into using the whole architecture. I don't know what to tell you, man. I can't seem to get this audio to work here. Let me try one last thing. I want to open up Zoom real quick and see what the settings are there, but I might have to just be your proxy the whole stream and just accept this is life now. Yeah, so Lewis says programmers suck. Programmers say technology sucks. Also programmers programs technology. 100%, man. It's insane. You know what I apart from using technology that I don't necessarily like, working in the biz, you often have to program technology that is not spec'd well and doesn't make any sense. So you're just like writing something and you're like, no one would ever use this. This is that's funny. I try to hold my speaker up so people could hear, but yeah, most programmers are against digital. What was it? How'd you say it? You said it in such a better way than I could ever say it. You had that Irish. I can't do it. I wonder if I could hook up my Bluetooth speaker and then just hold it real close to the. You sure? All right, man. Yeah, I can't figure it out, man. I'm sorry. I don't know. Do you want to hop off completely, or just be a beautiful face on the left side of my screen? You could be in the chat. I don't know. All right. So we'll just continue this, and sadly, Jason, I'm sure if he muses to me, I'll be able to repeat what he has to say. But we're just gonna roll with him being silent. I know. I'm sorry, man. Let me show. I'm gonna show Jason because I'm sharing my screen with him. What I'm seeing here, and what I'm seeing is. Maybe you can help me troubleshoot it. You'll be a rubber ducky. You got desktop audio to desktop audio. That's where you usually come in through those. Yeah. I'm just going to do that. I'm just going to turn all of these on. These are all on. For some reason, yeah, 100% volumes. The only thing I can think to do is restart. Let's see. An accent? An Irish accent. Pour me a pint of Guinness. How's that? I've been practicing that way too long. All right, so here you see I got desktop audio device 1 default and then 2 default. I could just try to send them to something else, see what happens. Let's do that. Yeah, what if I set it as something else and then set it back? Sorry guys, I'm not gonna mess with this too much longer. Just wanted to see if we can pull a Hail Mary here and get this working. And then lastly, I'm gonna go to my output here and I'm just gonna switch it from advanced. I can't. True. So let me go down to guest webcam. That's gonna be your portion of the screen. That's what I've called that. Yeah. I'm not seeing anything about audio here. Take a quick look. Maybe properties. Well, shucks, you know, I hate to say it, but this ain't looking good. And then I've got, you know, I've got all these things in here that. Mm-hmm. We'll just read Jason's lips. It's fine. Oh no, someone didn't like my Irish accent in there. Yeah, these are like the social, like the little videos that I have. Uh, I could call you on Skype, and then can I be on a Skype call and a Zoom at the same time? Uh, yeah, I'm out of ideas too. I'm sorry. Well, let me try this. I'm gonna switch scenes here. Maybe that'll work. Switch over to this scene, which is my programming scene. Test. Can you talk? Nothing. Yeah. Yeah. No. All right. Well, shoot. I'm sorry. I don't want to belabor this. You know, you got your wish in a way. There, Jason. All right, cool. I'll switch back to my. All right, cool. Sorry, man. All right, well, I'm going to switch to my single view here. Let me make sure I have all that all set up, and then we'll just continue. Look at that. It works. Something works. That's a start. Okay, let's take a look at this chat here. Sorry, guys. I think, Kristen, when you edit this video or do your clips of this stream, cut all this out. Start the clips now. All right, so let's see what questions we got. Do you ever put classes inside of other classes, and what would be some reasons that you would? Yes, in fact, in this previous video I did, I can actually probably pull up that code. Yeah, basically, I would probably nest classes for like syntactic sugar. Yeah, poor Jason. I would nest classes for some syntactic sugar, like for instance, maybe if it's like an enum, and if you have, well, what's a good example of enum? Maybe you have an input class. I don't know if this is a great example, but there's some finite numbers, finite input options like up, down, left, right. So maybe I would say like the class input has all the methods and static, or rather state, all the state that it needs to hold for input, but you might have an enum nested on there so that I could say input dot direction dot up, and that's just something, because I find that sometimes when you're writing something like an input system, you might prepend a whole lot of classes with the word input just to signify that what's direction. Oh, this is input direction, because even when it's in a namespace, you might want to be really explicit by using a class name that has the word input in it, that this has to do specifically with input. So in that case, I might explore, nesting that enum in the class. What we did in the video that we showed on Sunday was I actually had a data class that I nested inside of the job. Or was it the job? No, it was the building. So I can call building dot JSON. JSON. Sorry, I read Jason in the chat. Building dot data. I'm sure he'll have a good laugh at that. So then now if I want to make a data object for buildings data, instead of having a class called building data, or even maybe more confusing, having like a namespace called infalliblecode.building and then having a data class in there, then what I preferred to do was actually have the data class nested inside of building. So I would just say new building.data. And what's interesting there is that you could have private member variables in the building class, but still actually be able to reference them in the nested class. So that would be another reason why I would nest a class, is to get access to private member variables in case I wanted to do some initialization work or something like that on building. So there's definitely some interesting use cases there, but that's why I would do that. Let's see. I saw someone also respond to your question, coding with Unity. Sometimes if the classes aren't really supposed to be used outside of the context of the original class, possibly if a class returns a result that is a data class. Yeah, so something like, yeah, exactly. Interestingly enough, since the topic of this stream was like the job system, when back in 2018, when I really played around with Unity ECS, That was kind of like the approach, is that you would define a system, and then nested in the system, that's where you would define the job. So all your jobs would be named job. And in fact, in this video that I did on Sunday, I might even explore having nesting the job class that I wrote. So it'd be building.data, building.job, because, when you think about something that Jason and I talk about a lot, is kind of hiding the implementation details. You don't want to expose too much. So by exposing, I kind of had to in this case with the video, with the building example, I had to have a building manager that was aware of these jobs, of the job. So maybe nesting it wasn't the best idea. But if there's an opportunity for me to hide the fact that I'm using the job system, I would try to do that as much as possible. And so that's something we could actually explore probably later on when we open up the code. Let's see. Another question here. Do you have any more thoughts on whether or not to adopt job system ECF stuff in ongoing projects? Is it simple as, if you need performance, go for it? Yeah, it's definitely not as simple as that. Now, in the video, you saw that we sort of were able to get away with using the job system in a way that was like non-destructive to the project, meaning I didn't have to I had to make a slight change. I had to shift where the work was done on buildings. But all that to say, the job system is still in preview right now. So unfortunately, I definitely would say do not use it at all in production until at least it's a verified package. So for those of you who just don't know how that works, Unity right now, they're really moving towards this package based system of releasing features. So if you open up the package manager now, you'll see everything from the visual scripting graph to the scriptable render pipeline. I'm seeing I saw that I froze in my preview, by the way, in the live stream. So if I freeze again, just let me know. It looks like I'm getting some pretty low frame rate, or a low bit rate. Anyway, so yeah, Unity is moving over to this package-based thing, and you'll see that some packages will say preview. They'll have a little tag that says preview. Most packages will have a little tag that says verified. In fact, you can't even see preview packages unless you go to the advanced section of the package manager and check off a little checkbox that says to explicitly show preview packages. So Lewis says that he thinks in 2020.1 it'll be fully implemented. So when that happens, it's a great option if you need to leverage multi-threaded technology in a simplified way. Because the job system really does simplify the approach to multi-threaded code. It's really nice in that sense. You don't really have to think about it too much. Some low-level details are exposed. For instance, having to dispose of things like native arrays and native objects. But they're making a lot of changes to make it very easy to use. So so Prompt verified that DOTS 1.0 release is targeted for 2020.1. So that's pretty interesting. That'll be good. So yeah, when that happens, then maybe I'd suggest using it in a production, environment. That being said, again, I'm not, I would not call myself a job system or DOTS expert, but so I would take it with, I would be cautious, because this is still new technology, even though they've been working on it since 2017, I believe, maybe 2018. It's still relatively new in the grand scheme of things. And I know that, they're pushing to make ECS the approach, Unity DOTS the approach moving forward. And I'm not sure if they want to make that 100% the approach to Unity development, but it's still in the beginning phases. It's like, they suggest not updating the OS on your phone when it first comes out, because there's always bugs. So it depends on your situation, depends on your project. But be very cautious. So Simon and Russ asked, I've tried getting started with DOTS a couple times, but it was way too painful and not stable. Wondering if now's the time, or is it still changing? I actually asked this when I went to Unite in LA in 2018, I was just, I mentioned, I think there's actually, I asked a question in one of the, in one of the talks. It may have come up in one of the videos, but anyway, my concern at that time was I was trying to educate folks using my YouTube channel on dots and DCS because I really liked it, and I still do. But like you're mentioning, it was changing a lot and changing fundamentally, meaning even the way that you write the code was changing very rapidly. And plus, as I saw in the chat just now, they don't even have UI for dots. They did at the time that I asked that question. They didn't even have animation. I think they have it now. They had a rudimentary physics, implementation, I think. And so it's one thing to say, hey, we haven't added all the features, which is like what we just mentioned about them not having UI. But another thing completely to say, the way you're writing it now is going to change in 6 months. Now, to answer your question, I honestly don't know. What they told me when I asked was we're trying very hard to get to a point where the way you write the code is not going to change very much. And I can actually start to believe that because now they started adding lambdas. So in ECS, if you're using systems and all that, if you want to schedule a job on a group of entities, now you can actually call entities dot, I forget what the method name is, but maybe it's entities dot schedule, and that is a lambda that you pass in work. You define your work in that lambda function, and that's your job. Now you no longer have to actually implement a job like we did in this video here on Sunday. So I think when I see link style interfaces and a contract like that, to me it seems like they're getting more mature. They're starting to they're starting to visualize how users are actually using their Unity ECS and dots, and then they're working towards that syntactic sugar that probably won't change. And I know that they're aware of that. I mean, they're not. I don't believe that they would go to the trouble of providing syntactic sugar if it was going to be a one-off or a temporary thing. So, yeah, I think it's getting there. That was a roundabout way to say I don't think it's time now, but I think it's close. I think there's a lot of things that they're not going to change. And Tron says he wouldn't use it project wide, and I agree. Which is actually why I did the Sunday's video in the way that I did, because I've covered Unity ECS in the past, and yes, things have changed, and I'm going to definitely have to do a refresher video on that. But as I started developing this video, I was just like, what's an approach I can take that is different but also valuable? And the value that I was trying to share was that Unity DOS is very it's a game changer. It's a mind shift, it's a paradigm shift. Your whole approach changes. And I wanted to show, and this is something that I found organically, like you can use just the job system, and to great effect. So I wanted to show that, look, you don't need to make a project-wide change here. You could pull in the package, you can hide your implementation, which I did in the building manager class. It's hidden there. You don't have to worry about jobs anywhere else in the entire code. And you could still get multi-threaded optimization, or the optimization that comes with multi-threaded code. So yeah, it's nice. You don't have to make a project-wide change with the job system. You can pull it in, you can play with it. You might be, well, I'm not even going to say you'd be safe using it in production now. I don't even want to be quoted as saying that, because it's still a preview package, so don't use it. But when it becomes verified, some folks might say, heck no, I'm not using that yet. But if you are feeling ambitious, you might be safe to just use it in one or two spots where you really need optimizations. Maybe you have some CPU intensive code like we had in the video, or maybe you're on a mobile device and you want to just, one of the things that they tout on the job system documentation is that it's supposed to improve battery life. Just the way that the code is compiled and the data is stored in memory, that is supposed to improve the performance of the battery life of your phone. So yeah, definitely that's what I would say. Job system, I like it right now because it's not a full sale change. Let's see, what do we got here? Oh, what are your thoughts on visual scripting that's eventually going to come to Unity? I don't know. I've used visual scripting, and what did I use? Bolt. I used Bolt a while ago, and I did a video for them actually. And I think when I first, started using visual scripting, so I like visual scripting, and for those who don't know what it is, it's kind of like if you ever worked with the shader graph, or trying to think of pretty much that's the only example I could really think of. It's like this node-based approach to programming, where you grab a node and it represents some small unit of work, like maybe it's a addition, and each node will have inputs and outputs. So if I was going to add two numbers if I was going to program it by hand, I would create maybe two int variables, int1, int2, or my num1, my num2, whatever. I'd have to write that out, and then I would add them. So I'd say my num1 plus sign my num2, and I'd have to pump that into a result variable. And if I wanted to print it out to the console, I'd have to write print and pass that in. Now with visual scripting, each one of those items that I just mentioned is an actual node in a graph. Like it's an actual graphical visual thing. So you drag in a node and it says add, and then it has two inputs. So then what you can do is you can get another node that's a literal int that you type in a number, 1 or whatever, and then another one, you drag that in as a node, and then you drag both of those nodes as inputs into this addition node. And then if you wanted to put it out on the console, you have to add another little node to your graph, and then you have to drag the output of the addition into the input of the print of the debugged console node. And so it's this approach where you're not typing anything, you're still thinking through things logically. And when I first used that, and Bolt was my first time I ever used that, I thought, okay, this is cute. It's interesting. It's shiny and different and kind of fun to play with, But honestly, I've never used it practically. I've never used it in production or for any real project other than me just playing with it and, doing hobby projects with it. And I felt like, for me, I first of all, I'm a faster typer, and also like thinking through things, I'm just quicker, and I feel like I have more experience thinking through, trying to envision how a system would work. I have more control, and I have a better understanding and more experience just typing it all out and being in the code and defining classes using object-oriented programming approaches that I've studied for so many years. And with visual scripting, it's great. Like I see a comment here, it's great for designers, and it's great for prototyping. But I think you will reach a point where you're going to be limited. You're going to get a point where you're going to have some really complex need. Maybe it's bad example because this already exists in 100 different plugins and assets. But let's say you're like, I really need to implement like A-star pathfinding. How you do that in a visual scripting tool, I'm sure it's possible. But I'm also sure that it's difficult and it's complicated, and the graphs that you have to create to do this are probably nested and weird and have all these little tricks that you use to make it work. And on top of that, visual scripting provides a lot of overhead because from what I've seen, granted, I don't know what Unity's doing with their visual scripting tool, and maybe Bolt has some optimizations and maybe it compiles to some sort of compilation. I'm not sure about that, but from what I am sure about is that there is a lot of overhead, at least in the editor. So I would say it's great for prototyping. Visual scripting itself, I see Tron says it'd be good for cutscenes and level design, and I can see that. Not really level design. I'm not sure. I just haven't thought it through, so I'm not 100% sure, but definitely cutscenes. I could see that. And at that point, is it really visual scripting? To me, that's more like using the timeline, which I think the timeline is I don't want to say it's a more appropriate tool because that would be me not speaking from experience. The timeline seems like an appropriate tool for making cutscenes, but I think the graph, the node based approach is a very cool one. I like it for shaders, and I think it's also used for the visual effect, the new visual effect pipeline. I don't know what it's called in Unity, where you can make some really cool effects. You use graphs to approach that. For coding though, I don't know. I'm a programmer, so my answer is going to be like, I don't like it. But I'm trying to give a nuanced response here and give it its due. I've used visual scripting, and I just think that it has limitations and it has a lot of overhead. So, all right, we've been streaming about 30 minutes now. I think is a good time to stop and say to please invoke that like button. I don't know. I'm still workshopping that, obviously. I think I'll be workshopping it to the end of time, but hit that like button. Let's YouTube know that you're enjoying the stream. And soon I think we can pop into the code here. I think we're getting to a good point. Tron has a pretty interesting opinion there. Refusing to learn or do scripting in C# as a designer is a very bad trait. Now, what type of designer? Are we talking a game designer, like just a high-level ideas guy who just considers them like a game designer, or are we talking like an artistic designer, like someone who is a modeler or a graphic designer, UI designer? Because I think if you're a game designer, it's kind of like being the CEO of a company per se. Because like the word game developer is kind of, what does it even mean to be a game developer? Does it mean that I can do 3D modeling? Does it mean that I can make pixel art? Does it mean that I can program? Or does it just mean that I can use Unity and pull all the things that I need in order to make a game? As a game, what is a game developer? Because if I say I'm a game developer, if someone says to me, I'm a game developer, I don't really know what they're capable of doing or what they even be expected to do. Now, you can say I'm a game programmer, you could say I'm a programmer and I have experience with Unity. That's one thing you could say. You can even just say, I'm a graphic designer, I'm an artist, but doesn't mean you make art for games, So it's, I think if you're considered a game designer, or even if you really want to consider yourself like I'm a game developer, that's who I am, then you really need to be able to touch a lot of different things. You got to be able to touch code. You got to be able to touch custom tools. You have to be able to design custom tools for your game. Maybe not implement them, but certainly design them. If you're designing or developing a game, that means you have a vision for the entire thing. That's the art style. That's how the audio is going to sound, the mood. That's the story you're trying to tell. That's the approach you're going to take. Is it going to be first person, or is it going to be third person? Is it going to be pixel art, side scroller? Is it going to be 3D with like hyper realistic graphics? There are so many things to consider. What platforms are you going to deploy to? Is this going to be a mobile game, or is this going to be a PS4 exclusive, or you're going to put it out on Steam? What's the voice of your game going to be? Is it going to be like cyberpunk? Like if you go to the website for your game, is all the language going to be like super cyberpunky and like colloquial and irreverent or whatever? Sometimes you'll see websites, and you read through some of the about us page, and it's really funny and fun to read. Or is your game going to be like just a mobile game where it's just a game that players use to waste time while they're sitting on the bus? There are so many things to consider if you consider yourself a game developer or a game designer. And if you consider yourself one of those, like that type of person, then you need to be willing to be able to touch all of it. You know what I mean? Like everything. Code. You need to be able to open up, an art program like Photoshop. You need to be able to type and write, because if you're going to put a website, a description for your game out on the App Store, that's something that you're going to have to figure out and write and figure what's the voice of your game. What's the core demographic? What's the audience you're trying to appeal to when you make your game? A cyberpunk game isn't going to appeal to folks who want to sit on the bus and play Flappy Bird, and vice versa. So it's very interesting tangent I went down here, but basically, it's something that I think about a lot because I'm constantly coming up with language for, infallible code, my channel, descriptions, and I have to consider a lot of those things. Like who am I trying to talk to here? What is a game developer? And so, yeah, I don't know. So anyway, what Tron said was, if you call yourself a designer, then what? You're a potato? if you call yourself a game designer, I forgot what you said. Oh yeah, refusing to learn or do scripting in C# as a designer is a very bad trait. So if you're talking about being a game designer, then I agree, because you need to be able to do everything. Not necessarily everything good. And I guess I should point that out, because I said that being a game developer or designer is like being a CEO. It's kind of like you're running a business to some extent, depending on the level you're approaching this whole thing, being a game developer as. You have, if you're a game developer and you say, I have an idea for a game and I want to make it a reality, you're not going to do the whole thing by yourself. You're going to have to get a publisher involved. You're going to maybe need to hire an artist, a concept artist at least. You're going to need to speak to someone who creates audio. Maybe you find a song that really fits the vibe of the game that you're trying to approach, and you need to contact them, reach out and say, hey, can you produce more music for the game? And then you have to explain to them what your game's about and all that. So yeah, all this to say, you have to approach it like a business, and that means that you're going to have to pull a lot of pieces together, and you're almost going to have to be an orchestrator. I think that's what a game developer really is, an orchestrator. And if you think of what do you call a conductor? A conductor. So if you think of a conductor of an orchestra, conductors of an orchestra probably have a deep understanding of all the different instruments. They understand percussion, they understand rhythm, but they also understand strings, violins, the nuances of that. Someone who is trying to get the most out of their band and write music for a band, you need to understand what are the trombones going to sound like when they come in on a low note with these violins and cellos who are building, a feeling over on the other side of the orchestra. All those things, really matter. So yeah, being a game developer, that's just something that I've been chewing on for a while, trying to really piece together what I think that is. And that's the tangent I decided to go on just there. So, potato in some circles is slang for jack of all trades. Oh, I didn't know that. Thanks for explaining that. So yeah, I'm definitely up early. We just observed daylight savings times here, so I lost an hour of sleep here, but I wanted to keep the stream at 6 a.m. Eastern Standard, because that's just what I've been doing. So a little tired this morning, and unfortunately, I'm going to blame it on that. Daylight savings is why Jason isn't here, because we couldn't get the audio working. I blame it on the time zone change, or the time change. All right. Well, I've been rambling for about 10 minutes or so. Why don't we pop on over to the code and take a look at the code from the video on Sunday. So switch on over to that now. Now, again, I want to preface this by saying I am not a job system expert. I have spent a fair amount of time messing with it, but obviously I've never used it in production because it's not verified. And really, the extent of my knowledge was born out of reading a lot of documentation and messing around with it, but doing that in 2018 when the job system was pretty new. It's still kind of, I wouldn't say it's in its infancy now. It's probably more of like a teenager, maybe it's like entering middle school. So what I have done here is, in this video, just tried to take some code that was performing poorly and do my best to leverage the job system as it is today as a preview package to get some optimizations. So let's take a look at this project first. I'm going to switch on over to Unity. So here we can see the project, the scene here, and if I go ahead and just press play, we're gonna see what we're dealing with. So press play. We can see we've got some ships animating, and I don't know if it's if you can tell or not, but the frame rate isn't the best. It looks very jittery. So if I was game developer and I was looking at this and I press play on the scene, I would think this is no good. I only have 3 ships in the scene. I want to definitely add more ships. So I have to think through, well, first of all, what is the problem? Why am I getting such poor frame rate? And is there an option for me to be able to fix this? Now, you notice the first thing I said wasn't, oh, I'm getting a poor frame rate, let me get the job system into here and see what I can do. I don't even know what the problem is. So if I go ahead and look at the stats, I can see that the CPU is taking about 50 milliseconds to process each frame. That's what what's going on here. I can see obviously the frames per second is 20 frames per second. And I can see that this number here represents how long it takes each frame to process. So now if I was going for 60 frames per second, I would have to have at most 16 milliseconds per frame of process time. But it's taking way more than that. It's taking 40, 50, almost 60 milliseconds per frame. So that's my first indication. I can see something's happened on the CPU here. So what I'll do is I'm going to go ahead and open up the profiler, because that's going to really help me understand what's happening. So as we open up the profiler, we can see that there's a couple of profiler modules. The issue might be with my physics, might be with the UI. Maybe I got too much going on in the UI. Could be with the video, I got a video playing that's slowing me down. Could be in memory or the GPU. There's a lot of things it could be. For instance, maybe I got my scene just poorly optimized. But in this case, I think that I think it's the CPU, and I can tell because as I look at this graph, let me go ahead and pause that. We can see here this y-axis represents the amount of time everything is processing, everything that each frame is taking to process. And you can see here that, sure enough, 16 milliseconds should get us 60 frames per second. That's this line right here. But I got a whole bunch of blue here that's going way past that 16 milliseconds, all the way up into the 60s. So that's definitely not good. So what is that? Well, I can start to tick these off. Rendering, that ain't it. Scripting, well, obviously that's what it is. But I can pop through here and say, it isn't scripting, it isn't animation, isn't garbage collection, it's not the VSync, isn't global illumination, UI. Other looks, I'm not sure what other is, but it looks like it's certainly going to be scripting. Right, okay. So if I look over here into this timeline section at the bottom, now I can actually see it. What's in the timeline represents what's happening in the frame. So as I click through, you see how it's changing. So if I zoom in to this highlighted area, this represents the entire frame. We can see we've got the player loop. The player loop is taking 53 milliseconds to process. And if we look even a little closer, as a hierarchy goes down, in the player loop seems to be that the update.script run behavior update is taking that long. So that is basically Unity running the update on all of my scripts. Again, we move down. Finally, we can see building.update. And sure enough, there's a whole lot of these running right now. And each one's taking about 1.3, 1.4, some are less than that, but they're taking around 1 millisecond each to process. And we can see we've got 65 instances. So that's pretty much in line with what we're seeing here. Now, if we wanted to dig a little deeper, we could actually click on the hierarchy here. And you'll see that if we sort by time in milliseconds, we're sorting by the time it's taking each of these elements to process. So we've got the player loop, the editor loop. The editor loop is eating up 2 milliseconds per frame. Go ahead and dig in a little deeper. We can see that again, just like we did with the frame, it's a hierarchy. We can dig down, and then sure enough, we see that same information here in this graph, and we can see that building.update is causing us some issues. Well, watch this. We can actually go a little deeper. Let me stop this, and I should be able to turn on deep profiling, and then the call and take a look at the call stack. I don't think I really need to look at the call stack, but this is going to actually show us more information. Now, deep profiling, there's a way in Unity to actually add snippets of code they're just calls to a singleton. I'm not sure what the call is, but basically you can say, hey, look, just in between these two calls to some, it's like some profiling class, go ahead and add that to the profiler so I can take a look and see what's going on there. But if you click deep profiling, you don't have to add that call explicitly. It'll add everything to the profiler. So let's go ahead and press play and see what it's going to add here. Hit play. Now it's going to take, I think it's going to take a little bit longer because deep profiling is very expensive. Yeah, look at that. It's chugging along. That's okay though, because we turn on deep profiling. And now if we do the same digging that we did before, now you'll see that building.update, I can actually dig in. I can go in and look into this nested view. And then we can see, what's going on here? We got a call to random.range. We got a call to building.set power usage, building.get power usage. So these are getters and setters. And if we dig in, we can see that this is going even deeper into the random.range, and it's letting us know that we've got these calls in here, and these calls make up what's happening in update and what's affecting us negatively as far as our low frame rate goes, and how each frame is taking so long to process. So at this point, I know it's not the graphics. My scene's fine as far as that goes. The lighting's okay. There's not too many game objects. Well, there are, but the problem is that this script right here is just getting run too many times. So what I'm going to do is just stop the scene, turn off deep profiling because I will forget, and then we can switch on over to the code and see what we can do about this. So we'll turn off deep profiling, make sure that's turned off, and let's switch over to the code. So sure enough, here's the building class, and like we saw in the profiler, that update method was what was causing us our issues here. And we can see that, yep, there we go. We've got the random.range. That was something that appeared, and then we saw the getter and setter of power usage. And what's happening there is we have plus equals. So really, what that will compile to is first it's going to get the value of power usage, and then it's going to set the power of usage to itself plus random.range. All right, so this is expensive. Now, what am I going to do? I can't just get rid of this. For whatever reason, I have to get a random number, right? So are there other ways to optimize that? I don't really know. For me, maybe the requirement of the project is I have to get a random number. Now, I could try to explore ways to optimize the random and how to calculate that. That's certainly an option. But obviously, well, maybe not obviously, but another option is I know for sure that there's just a lot of these buildings running and they're all taking a turn on the CPU. What if I could just get them all to run at the same time? Because they don't affect each other. They have no knowledge of each other. So realistically, I should be able to put them on their own separate threads, and it should really have no effect. Now, the other thing you might think is, well, why not maybe just put this in a coroutine? Okay, well, the problem with that is that a coroutine isn't actually multi-threading. And a coroutine is going to spread the updates of the buildings across multiple frames. But the requirement of my project is that I need all of the buildings to update every single frame. So every single frame, I need each one to update. Maybe I've got something in the UI, or maybe there's some dependency in some other calculation that's more important, that just needs to know how much power each building is using on every frame. But if I use a coroutine here, it's going to spread the updates of building across multiple frames, and I can't have that. I need every frame. I need to know what the current power usage is. Now, of course, a rebuttal to that is, well, your requirements don't make any sense. There's no need for that. You should be able to have some sort of threshold where you can say, look, I'm going to grab the average of every 5 frames or so, or 10 frames. And in that way, you don't need to use multi-threading. And that's a very valid point. But this is a video about the job system. So let's just pretend, let's work off of the assumption that from the higher ups, I'm just a programmer here, the game developer who knows all, says I need every frame. I need that's the granularity I need here. So I said, all right, well, fine, every frame, fine. What do I do here? Well, I reckon I have to leverage the job system because I need multi-threaded code. And that's the only way I know how to do multi-threaded coding in Unity. So let's go ahead and do that. What first we're going to need to do is make sure that it's included in the project. And I see that it already is. But for those who don't know, you're just going to go over to the package manager and we're going to do a search on jobs. We have to make sure that we are not looking in my assets, but rather looking in the packages section. So, it looks like it's frozen. Let me just close that window, open up the package manager. We're going to go and select all packages. And then because jobs is in preview, we're just going to make sure that we've got the show preview packages checkbox selected. And if we search for jobs, we're going to see that it's here. And of course, it's in the preview package version 0.2.6. So supposedly 1.0 is coming out in 2020.1. So that'll be interesting to see how that looks. But we'll just move on. So Andrej says a more realistic setup would be assigning apartments and having a logic to determine when the light in a window is on or off. Dang, that would have been a really cool one. You know, it's funny, as I made up this example, which is always a really hard thing to do, I was like, I really want a way to visualize this. Like, it's kind of lame that I can't see power usage anywhere. And I actually found a little lightning bolt icon, and I put it over every building and put the number so you'd see it changing. But it just looks so cluttered. Man, a light in a window would have been such a cool example. Maybe when I do a Unity ECS video, I'll do that instead, because that's so cool. You can have the light turning on and off. Oh well, what are you gonna do? Can't win them all. All right, so now that I've got the jobs package in here, the first thing I'll need to do is define a job that has this calculation. I want to jobify it, if you will. And so what I'll need to do is just create a job. So I'll go ahead and just do that up here. We'll move it later, but I'm going to make a job. And so first thing you might think is, oh, I'm going to make a class, make a job. I don't know, my job. But I'm going to call it what I call it in the video. We'll call this the building update job. We'll just make it real on the nose so we know what's going down here. Problem is it can't actually be a class. It's going to have to be, we're going to have to make this a struct. So the job system doesn't support strongly typed classes because of the way it stores objects in memory. It stores all the objects right on top of each other and as close as possible. Now that's more of a function of Unity ECS, because with ECS you have components living on entities, and so it's very, very optimized in how it stores all the components together next to the entities, so that when it goes to grab the components off of an entity, it doesn't have to go that far in memory, which is, you know, a very small order when you think about it, but it adds up over the long run, especially when you've got a lot of entities in your scene. So we'll go ahead and we've got this building update job, and there's a couple of jobs to choose from here. I'm going to type in iJob, and hopefully there you go. We got iJob, we got iJob Parallel 4, we got iJob 4, iJob Particle System, interesting, Parallel 4 Transform, all sorts of things. There's so many different types of jobs. Most you'll never, ever have to use, because typically when you're using Unity dots as a whole system, it's doing all this work for you. It's even deciding what type of job to make. In our case, we're going to go ahead and explicitly choose the iJob Parallel 4. So what is that? Well, that's like a for loop, but a for loop that's happening in parallel. So this for loop, it's you don't actually ever call execute explicitly or the index, but what you do is when you schedule a job that implements iJob Parallel 4, when you schedule it, you pass in a number, and that number is basically like saying how many times to iterate over this for loop. But you don't actually have to iterate yourself. By calling schedule, it'll start the job and iterate intelligently, but it iterates in its own order. So maybe the first time it executes, it'll call index 100. Then the next time it'll call index 100. Or 1, and then 3, and then 5, and then 20, and then 30, and then it's just going to go in any order that it wants to, which is why it's important that our logic here, and the reason why we chose this, it's important that this logic is isolated. It's like a pure function. It just it's taking an input, doing work on it, and then updating some variable. Now, if this logic needed to know about some other part of the system, then you're going to run into some issues, having a collaborator involved. But because of this, the way I created the example, this is just a good pure example. It's just a for loop. And what we're going to do is spread that for loop across all of the threads on our CPU. So first things first, we'll just copy this code. We'll yank it and paste it in here. And then we're going to need to add some properties to this building job that we'll pass in. And so we'll go ahead and just make them public. I'm going to have a public int for tenants. And then we'll also have a public int for power usage. So we're just going to update this. So that's the logic. Now it's totally been jobified in here. Now, the problem that we're having is I actually need this information to live in the building class. And this was an issue that, I didn't really cover in the video, but I can't just pass in tenants and power usage because you can't iterate over that. It'd have to almost be like a list of ints that represents the tenants and a list of ints that represents the power usage. And then those lists would actually have to be in the exact same order. So instead, looking at this, I think I'm going to have to keep this data in the building. So I think we're going to just take an iterative step here. Instead of putting it in there, now that I see that, we're going to go ahead and add up here a nested struct. We're just going to call this data. So that's going to represent the building's data. And all this logic, I'm going to go ahead and copy it, and I'm going to paste it in here. All right, and I'm just going to rename this to update because I don't want to use the word execute. So we're going to update we have this data struct, and now we have the ability to just update the data of the building whenever we call it. So now that we have that, instead of passing in tenants and power usage, or what I'd have to do is actually pass in a list of those things, why don't we go ahead and pass in a list, get rid of this, we're just passing a list of data. So we'll just call this building data array. So we'll pass in a list. Cool. Yeah, that works. That seems like the way to go. And then now, because this execute represents the code of a single iteration of this parallel for loop, I'll go ahead and just call building data dot, and then I'll get the int, the index, and I'll just call update. All right. And let me just remove this. We don't need that. We don't need that in the signature of update. So boom, that's great. Now, if I schedule my building update job, it's going to run in parallel. It's going to iterate and run this execute method. And now, as long as I pass in a building data array, I can just use the index to update each building's data. That's pretty cool. However, there are some issues. And if you saw the video, you'll know what these are. But first, list is a class here. So again, that's not supported by the job system. It going to have a negative effect on the memory layout. And of course, I don't even think it'll compile. I think the compiler is going to say, hey, you can't have a list here. Or worse off, it will compile. And when I run the scene, it'll complain about it. So we need to use something called a native array. There's also a native list, and there's a native queue, a native slice. There's things like native strings. You need to use a string, all sorts of these native types. But these are a part of the unity.collections namespace, which is a part of the whole dots infrastructure. And we'll go ahead and we will add a data array. He's like, no, Andrew says, don't call it building data array. It's a list. It's funny. I never would have called it array. I just knew where this was going. So that's why I called it array. I don't know. I can call it building datas or building data, but that's a funny catch. I never would have called it a list, I promise. But all right, so now we're able to actually use this native array. So the native array is something that's particular to job system, and it's something that's supported by this job. Another thing, because we're using this native array, if it was a list, I could go ahead and just use the index to call the update. But you can't actually do that. You actually have to pull the data out first. So we're going to introduce a variable. We're just going to call it data. And now that I've pulled the data out of the array. I can call update on it, but I also need to pass it back in. So I'm going to reference the same index, and I'm going to pass that data back in. And that's going to allow us to actually perform the update. Otherwise, the information, you're going to lose the changes. The update's going to be lost. So again, I'm not an expert. That's something I learned the hard way this week as I was developing this video and learning more about how this works. And I called it a quirk, and someone called me out in the comment section saying, "Hey, it's not really a quirk. That's just how it works. You know, when you're using a native array like that, you can't just the way the underlying code is set up and the way it compiles. You have to pull the data out, change it, and then pass the data back in. So yeah, that's just how that works." Yeah, so this is a good point I see in the chat. Just a good point to pause as we have this first job we've created. Vargonian says, "My worry is that the new system is that it's going to sacrifice code readability." And you're not wrong. You know, it is going to sacrifice code readability. There's no way around it. And that's just the thing. You know, and that's the thing about the job system in Unity Dots. Because it's a means to an ends. If you have a situation, if you have a project, a game, or a simulation that requires this level of optimization, then at some point you're just going to need to accept that, well, I'm going to have to sacrifice something, because you're not going to get code readability and good performance. Now, obviously, that's a very broad statement, because you obviously can get good readability and just fine performance. I'm talking about the edge case where you have some code, like a simulation, that is so unperformant and there's no way around it. Because like the example with the windows that Andrej brought up, you know, you'd probably just fake that. You know, you could just use a shader that you pass in a percentage of the windows being on or off, and the shader has some intelligent way of setting certain parts of the texture to use an emission. You know what I mean? Like you'd get around something like that. And that's part of what you do in game development, is you're always finding a way to cut a corner, to be creative. But in the case where you simply just have something that you can't avoid, like an A-star pathfinding algorithm, or maybe your game, one of the requirements is that you have procedural generation, and it's very complicated procedural generation. There are some instances where you're just going to say, well, I need this, and now I need to make a compromise. And the compromise you make is you use Unity Job System, you use Unity Dots, and your code suffers in readability. And not only that, but if you're using Unity Dots as a whole, you're actually going to have to change the entire way you approach developing in Unity. So that's just something you need to take with a grain of salt. And it's an interesting thing because, you know, I see a lot of excitement for the Unity Job System and Unity ECS and the Unity Dots. I see a lot of excitement, and I'm excited too. But I don't think a lot of developers understand that this is just a tool. You know, it's a means to an end. It's a means to getting extreme optimizations, both for battery performance and for just the performance of your code. But just think, how often do you write code that is this CPU intensive? Now, even when we were looking at this update method, I offer, you know, we talked about some ways you can get around it. You know, does my game really need to know every single frame, every single building's power usage? I might be able to say the compromise I might be able to make is, no, I don't. I can spread that out. I can use a coroutine, spread that out over 10, 20 frames. Maybe every 60 frames, you know, maybe give it a whole second to calculate. And then I'll take an average of that. You know, in that case, you don't need the job system. You don't need multi-threading. You can get around it. But again, maybe there's a case where you just have an extreme requirement and you cannot get around it. And so in that case, you're going to have to make the hard choice whether or not you want to dig in and use the job system. And for those cases, here's what you do. You make your job, and now you got to schedule it. So now that we have the job, we're going to go ahead and remove this update method. and we're going to also update the tenants and floors. Now, I should mention that because we've pushed a lot of this information down into the data object, we'll go ahead and we'll add an initializer here, or constructor here, and we're going to take in, well, we're not even going to take in a value for floors. We're just going to move this calculation in here, and we're going to set a default value for power usage. And this is complaining. I'm not really sure why. Struct cannot contain explicit parameters constructor. What? Really? Oh, wait, hold on. Let me see here. Oh, why did I not know that? All right, so we're gonna pass in a building. I'm sort of like on autopilot here because I know I wrote this in the video, but basically what we're going to allow happen is whoever creates this building.data using the constructor, they're going to pass in a building. Hold on here. Let me fix all this. We're going to pass. Oh, look at this. A bidling. We're going to pass in a building, and then we'll use the building's floors and a random range to initialize these two values, just like we did in the awake method. But now we don't need to do it in the awake method, again, because we jobified this code by pushing it down into the data struct. Okay. So now that we've done that, I'm going to move this field to the top. Let me just explain why I did that. The reason why I kept this as a nested data object, and the reason why I kept floors here is because I want to be able to manipulate floors from Unity's editor. I still want that, that tool. It is a tool to be able to drag a building onto a game object and update its floors. That's something that a designer could do. I could say, hey, set up a scene for me and make an, based on the model, set the floors of the game object so it's realistic. So I don't want to have to pump that into some sort of settings file. Just want to let them set it from the editor. All right, so I'll leave that exposed there. And it's a private field. So luckily, because this is a nested class nested within building, I can actually still access floors, even though it's private. And that's kind of some syntactic sugar that we get. Maybe syntactic sugar is not the right word, but that's just some nicety that we get from having this nested. I get to access the floors and now later on, the real syntactic sugar is that when I call building dot when I call the constructor new building dot data, I can pass in a building and it's going to populate all that information. I might even have a lazily loaded property called data. I don't know what you call it. I can't call it data because I've used that word as a type here, which stinks, but building, let's just call it building D for now. But I might do something where I have it in a private backing field. Call this data. I don't like calling this D. I'm going to call it the data. I'm sorry, I'll have to think of another name later, but I might do something like if data is null, then I'll go ahead and I'll set hold on, sorry, I'm having a brain fart here. I'm trying to use both a getter expression and the body expression at the same time. Give me a second here. Format that. If data is null, then what I might do is set data to be a new data object and pass in this and then return data. I don't know. This is garbage. Don't worry about it. I'm going to remove all this. The point being that you get syntactic sugar that we're going to see later on. We don't need to explore all that. Let's just move along here. We've got our data struct. Now we need to actually schedule this job that we have. So what I'm going to do is we're going to create a place to collect a list of these buildings, game objects, and then we're going to schedule the job and pass them in. So I'm just going to make a mono behavior called building manager that we can drag into the scene. And then we're going to give it a serialized field. It's going to be a list, which obviously I can do because this is a mono behavior. And it's going to take a list of buildings, call that buildings. And now in the update method, we can take our buildings and we can take our buildings and passing them into a building update job. But let's create the job first. All right, so we'll create a job It's going to be a new building update job, right? And here we can actually call building, like I said before, building.schedule. We're going to need to pass in a number that represents the number of iterations this is going to do. And again, this is going to be multi-threaded iterations. And we have a buildings list, so why don't we just pass in the count of that? And then we need to pass in a batch size, so that's how large or how many number of items are going to be on each thread. For now, I'm just going to put it at 1. I haven't really played around with what the optimal number is, so that might be something that we could do afterwards. But this is what's going to do all the work. Now, when you schedule the job, you never know when it's going to end. It's just asynchronous. It just gets scheduled and that's that. But again, the requirement here is that we complete this job every frame. I need to know every single frame. So I actually have to call complete on the job handle object that gets returned from this schedule method. So you can have this job, and eventually we'll move it up into a private member variable here, so we can schedule as many times as we want. But every time you schedule a job, it's going to pass back a handle object. So the job handle has some things like is completed, so we can just check to see if it's completed or not. Again, probably things you'll never ever use because you're going to use this in the context of Unity dots. But we'll go ahead and we're just going to call complete, and that's going to explicitly complete the job. It's gonna ensure that it gets moved up, and as far as the job scheduling system goes, however the back end of that works, it's going to move it up to the top and complete it, and that's how we know that it's going to be done when this frame is finished updating. So that's great, but we're not done here, because when this runs, unfortunately, this job expects to have a list of building datas, or an array of building data, and it's going to expect to be able to update the building data based on this index. We have not passed that in yet. So what we're going to need to do is make a new building data array, right? And that's going to be, again, a native array now. This is Unity's own type. We'll pass in building.data, and we're going to pass in a size. And we know that size is going to be the size of this building's list. And now that we've actually passed in some more information, we're ready to actually allocate memory with the size of buildings.count. We have to let the system know how long it's going to be allocated for. So we see we've got a couple here: persistent, temp job. We're going to use temp job because that is a specific allocator that is aware that we're going to be passing this into a job that's scheduled in the job system, and it can handle that. So Andrej asks, what's the type of the job handle? Let's take a look. I'm not really sure. I think it's literally type job handle. Yeah, it's job handle. So, oops. Job. Wonder if I can just click into control click in there is a thing in Writer that lets us pop into it, into the class. So we've got its struct, job handles a struct. Yeah, so there's a lot of underlying code here that you can see. All right, so that's what that is. Cool. All right, so now we've got our array. We've allocated it for a temporary job, however long that is. We're going to need to just iterate through the building data, or rather the buildings, number of buildings, because we're going to need to create a new building data object. And here's what I was trying to do earlier, but I had like severe brain fart, where I was just going to provide a lazily loaded data field. But we can just do it here. We're going to say new data, well, new building data equals, and then we'll do new building dot data, right? And we're going to pass in an actual building now. So we'll do buildings and then pass in based on the index as we loop through here. And what that'll do again is it's going to call the constructor of this data object, which is going to pull the floors, which was set in the editor, get some random number here, and then now we'll be ready to go to update these. So once we have that, we're going to need to pass it into the building data array, which we can do by, again, accessing based on index equal building data. Okay. So once this iterates through, we should have a nice fat list of, or fat array of building data, and then we can just pass it into the job. So we'll do that here. Building data array. Beautiful. And that's it. So not the best. Again, we've sacrificed code readability. Doesn't mean we have to sacrifice architecture. I mean, this implementation is still hidden pretty well inside of the building manager. So now we can switch back on over to Unity, and then we will go over to our hierarchy here. Click on the buildings. We're going to add the building manager. Oh, we have to move this into its own class file, or else Unity will ignore that. So move that into its own class file here. Right now that it's its own class file, Unity will know what this is, be able to expose it to us. So we'll again click add component, let that compile real quick. Add component, building manager, there it is. It expects a list of buildings, so we can go ahead and, little Unity tip, lock it. That way we can select all of our buildings in the scene and then drag them onto this list. And the other thing we're going to do is just unlock this. And now with all of our buildings selected here, I'm going to go ahead and... No, we're good. We don't have to do anything. I thought I had to... No, we're good. So everything, all the buildings are there. Our buildings list is populated in the building manager. Looking real nice. Now we can go ahead and just run the scene, see what we get. I know what we're going to get, but... And you do too if you saw the video. While this runs, if you don't mind hitting that like button, would really appreciate it. Just lets YouTube know, that you guys like what you see here. So, okay. So we'll go to the console. Well, I mean, we are getting better frame rate. That's nice. However, our building usage is not actually being updated, so the simulation is useless. Why do I know that? Because if you go to the console, you can see we're getting loads of exceptions. And that's because we're using a type, a class, the random class inside of our job, and that is a no. That's a pow. That's a no. You can't do that. So we're going to go back on over to the code, and we're going to go back over to the job. Now the job calls update on the struct, so implicitly we're using this random object. Can't use that. Luckily for us, there actually is a random class that's provided, or rather a random struct that's provided in the unity.mathematics library, which is a specific namespace that provides a whole bunch of mathematic functions that are designed to work well with Unity dots. So we'll go ahead and we will add a private member variable to the data struct, and on the constructor we'll add a new random here. You need to pass in a seed, so I'm going to pass in 1, but I got to explore what the appropriate seed might be, but we're just going to pass in 1, and now we can call random dot, and it's not random dot range, it's random dot next int. So we're going to call random dot next int. Now we won't have this dependency on the random class, the static random class. So it's going to be random dot next int. All right, and then I'm just going to remove this reference to the using statement. So now we've used a special random that lives in Unity mathematics, so that will actually work. Go back on over, hit play. We should see this clear up now. All right, so yeah, that's cleared up, and no more exceptions. The ships are running quite nice. We're getting definitely higher frame rate here. Oh, look at this. Oh, I'm glad I missed something, and I'm glad I did. So we see that we get an exception here that says a native collection has not been disposed, resulting in a memory leak, right? So if we can go back to our code, we did not dispose of this native array that we created. We allocated it for a short period of time, but we never said we gotta delete it. I never told the system, okay, go ahead, I'm done with it now. So now we actually have to call building data array dot dispose, and that is actually going to go ahead and dispose of the array. Now, someone mentioned in the comments that we could do using, so we could say using new you see building data array equal new. We'll just copy this over, and this is certainly another way to do it. You don't actually have to explicitly call expose. Let me do this here. Let's see what that looks like. Right, so now we don't actually have to call dispose anymore when you call it like this. I think, what's the problem here? Oh, it's immutable. Interesting. Well, yeah, I guess there's ways to go around it, but for now, I'm just going to go ahead and do what I did in the video, which is I'm just going to be explicit, and I'm going to call building data array.dispose. So I'm going to switch back to Unity Editor now that we've done that, taken care of that. Restart the scene. And things are looking much better. Now we can see that each frame is taking 3 to 4 milliseconds to process. And if we look at the profiler, you might think, well, how do you know the jobs are running? That's a good question. If you pause on a frame, go back to this timeline view, and we can see if we scroll in on the current frame, we got that I'll zoom in a little bit further now. It takes up less space on the screen. We got the player loop. It's running our script behaviors, our behavior update, and then it's going to run building manager.update, so we know that's happening. And then we can see that the building update job, it's running, and it only takes 1.5 milliseconds to run. Now, what's kind of stinks about this is that you see a whole bunch of empty space happening before we actually get to run the job. I could be mistaken. I think what that is, and we're going to explore this, is I think that's because every frame I go and I make a new job and I fill up this, native array. We're going to be able to optimize that, I think, but you can tell there's just so much empty space of like wasted time happening there. But nonetheless, if you go down to the job section here, I could be wrong about that, by the way. I'm going to have to confirm that. You can see that we've got the building update job running, and it's running across all of these workers, and those workers are going to represent, all the threads that we have. So that's pretty cool. All right, so let's see if we can get rid of this big empty space here. We'll go back, and we're not going to do all this work in the update. I'm going to go ahead and we're going to create an awake method here, and then we're going to just push these. The building data array and the job, we're going to push them into fields. So we're going to just use the introduce field of refactoring, make it private there, and I'll do the same thing for the job. Make that a field. And then now we can take these and move them up into the awake method, like so. And what I forgot to do in the video, which shoot, I didn't realize that until after editing, was we got to make this persistent. We got to tell Unity now this sucker is going to be around for a while. Also, we can't just dispose it after the frame. Again, we need it. So we're going to move this into on destroy. We'll go ahead, and that's when we'll call dispose on this. Okay, come on. There you go. We'll call it once the object is being destroyed. We'll dispose of it. So yeah, that looks good. Now we've got this optimized a little bit, and we'll go back into Unity. See if we get rid of that little chunk in the beginning there. This is where you're seeing a little bit of my lack of understanding of how, what the best approach is as far as, starting jobs and allocating things. See, we're getting pretty much the same frame rate. Click on that, and but you do see where there's no longer that gap. So I want to say that that seemed like it helped, definitely. Although something else is gobbling up some frame rate. I'm not sure what that is. Maybe that's just is what it is. You get this editor loop here, and it's always taking up some time, so you can just not avoid it. But we definitely we definitely removed a lot of work. It looks like we moved a lot of work out of this frame here, so that's good. The other thing I can play around with, and we'll just do this real quick before we call it a day because we're getting towards the end of the stream time here, is I'm going to play around with this number, the batch count. I'm going to do something that I would not recommend. I'm going to expose the batch count. I'm going to expose the batch count here in the editor. Now, I wouldn't recommend doing this because obviously you don't want to expose any sort of implementation details, and this certainly does expose the fact that we're batching this thing, and we're just going to pass that in here, batch count, and we're just going to give this a default value of 1. I should probably, if I wanted to be safe, I could put a range on it, but I don't know, it doesn't matter. All right, so let's set this to 1 and we'll press play, and let's see if the batch count, we can update that and if it'll affect anything as far as our frame rate goes. So let's update that to, I don't know, 50. Well, there's only 50 in the scene, so it wouldn't make a difference. My thinking here is that right now we have one. The batch count is 1, so that means that one batch is doing all. I don't know. Let's see. Let me just update it and see what happens here. This is part of the learning process. So I didn't see any particular effect. I'm looking at the size of the workers here, as opposed to, all right, so let's go ahead and just jack it up 10, see if that has any effect on it. Pause it here. I feel like I'm definitely seeing less of these workers being used, or maybe I'm seeing this time go up. It's kind of odd. Let me just go up to, let me do 100. See what oh, look at that. Wow, look how high I went. Ha! That's because, okay, yeah, I mean, that feels pretty in line. We're doing all the work on a single thread. So I think batch count. I mean, I have 60 objects in the scene, to be honest with you. So I think look at that. I think batch count, it becomes more important when you've got like thousands and thousands of objects. Obviously, you can't make your batch count 1 because it's like, you know. So you might say, hey, I'll do 200 in a batch, 500 in a batch in that case. So anyway, that's pretty much wraps it up. You know, I was curious to know what that batch count would do. It pretty much lines up with what I thought it would. Let me know what you think. I mean, like I said before, and I think this actually is worthy of a video. Just to say that, you know, Unity Dots and the job system, it's a tool, and a lot of people are excited about it, and a lot of people probably think, oh, that optimization sounds great. The optimization you're going to get sounds great. And it sure does, but you're going to have to make sacrifices. And so that you're going to have to weigh out whether or not those sacrifices are worth it to you. And what you sacrifice is code readability. That's pretty much the big sacrifice. And the you know, you lose the ability to architect your entire project using, you know, strong OOP practices. Now that's Unity Dots, you know, with ECS and all that. Now with the job system here, it looked like we were able to leverage it pretty easily within its own place. So, you know, we don't have to sacrifice too much. Our building manager maybe is a little hard to read, and if you don't know the job system, you're going to be like, oh, what the heck is all this? But it's really not that big of a deal. So yeah, things to consider. Thank you guys for joining. I'm sorry to Jason. I doubt he's still listening, because I'm sure as soon as I pulled up the job code, he was like, I'm out. But I appreciate the questions. I saw a lot of folks in here that I recognized from the previous streams, and I think that's becoming, you know, a thing now. I like that. I like seeing you guys here, because I'm learning with you during these streams as I talk through these things with you and get some great questions. I think we're all exploring these things together and learning. So there'll definitely be more job system videos. Not a lot, and probably few and far between. But you know, keep an eye out for those. And if you'd like to, you know, ask any questions that maybe we didn't cover in this video, in the stream, feel free to join us on Discord. We've got a growing community of game developers who, most of them are, you know, programmers like, you know, myself and Jason, come from a programming background, but are just getting into game development. So join us on Discord. There's a jobs channel. So, I think it's called Unity Dots now, the channel, or just Dots. But we have a lot of other fun channels. So just join us in there. You know, we got a lot of cool folks. And I'm going to try to schedule this stream. I say that every week, but now these streams are really becoming, I think Mondays at 6 a.m. Eastern Standard Time, they're becoming pretty standard. So I think that's what we're going to go with. Works out for me. Now I have the rest of the week to work on the Sunday's video. And I don't have to stress about going on stream with my day job, which, you know, I work 40 hours a week on top of all this. So Anyway, thanks for joining, guys. Be sure to like this video. I'm gonna have some clips, some highlights of the previous 2 weeks streams coming out, and so look out for those. Like them and comment on them. It just really helps. If there's any way you want to support the channel and you don't feel comfortable or maybe not in a good place to contribute financially with Patreon, the best thing you can do is just like these streams. Every time you see a video roll through, just give it a like and a comment on there, even if it's just a hey, I like this, or even if you want to tear a video apart, I'll take anything. This stream will be available for offline watching. So immediately once I end the stream, I think YouTube's gonna process it and then it'll be available. So please join in. The first 15 minutes are garbage. I'm sorry, because I was trying to work out some audio issues I was having, and we lost Jason there. So, but just muscle through it or click through to pass that, and then we get into some good conversations. So, okay, well, I'll catch you guys on Discord. See you later. Bye-bye. End stream. You can do it. You can do it, YouTube.